Now let me talk about permutations. Okay, so I believe everyone understands what is the meaning of permutations. So permutations means nothing but different arrangements. Okay, so let's say you have a string ABC, then a permutation of it can be CAB or CBA or BCA or BAC. Similarly, you can have many other permutations of the same string. Okay, so few things to be kept in mind is in permutation all the characters here should come over here. It can never happen that there is a string of size n and a permutation of it is of size n minus 1 or n minus 2 or n plus 1 or n plus 2, right? It will be exactly of the same size, and also the number of times this character is here, the same number of times this character will be here, and so on, right? So that is the definition of permutations. So let me ask you that if I ask you that, let's say this is a string, okay, so a string is given, okay, containing distinct characters only, so there is no repetition at the level of any character. Can you tell me how many permutations will be there? For ABC, how many permutations do you see? 3 factorial. That's quite easy to guess, right? So, and why is that? Why is that the case? Because as I said, any permutation of this string will be another string containing 3 characters, right? Now, how many options do I have for first character? So for first character, I have got 3 options, okay? For second character, how many options? So since one of the characters must definitely have come over here, I don't know what that character would be, but definitely one of them would have come, and as a result of that, now the remaining number of characters will be 2. So for the second slot, the number of options that I have is 2, and similarly for the final slot, 1. So 6 is the total number of permutations of this string, assuming the fact that the characters are all distinct. So if I try to generalize it, if the size of string is n, then the number of different permutations will be n factorial. Different permutations, number of different permutations under this condition that all the characters are distinct. So the question that I want to ask you is simple enough, that I hand you over a string and that string contains all the distinct characters, and I want you to generate me all the permutations of it. Tell me what are the ways to do this problem. How many of you can think recursively that how to solve this problem using recursion? Take some time, think out that how the different strings are getting generated. Okay, so with respect to this ABC, the different permutations are ABC, ACB, DAC, DCA, and CAB, CBA. These are the 6 different permutations of this particular string. Okay, loop and recursion. Okay, for ABC, make 3 recursive calls at each level. Okay, that is good. Can we use something like lexicography? If you want, you can use that. However, I am not interested. I am not forcing you to print the permutations in lexicographic manner. You can print them out in any manner. My only concern is that you should print them all out. Okay, so maybe I'll take first response, which one of you gave, and let us all understand, guys, this is a quite important concept, so you have to focus your attention because a different story will start from here. Okay, so let's say you have this string called ABC. Okay, now you want to generate all the different permutations of it. Okay, so to capture any particular permutation of it, you definitely need a separate temporary string or something like that. You need a temporary string. So let us have a temporary string with us. Okay, so that temporary string is initially empty. Okay, now what I am going to do is just fix an index I. Okay, so index I basically denotes that, hey, currently I want to find the candidate for my 0th position. Okay, currently I want to find the candidate for my 0th position. Okay, so if you want to find the candidate for your 0th position, how many options do you have at this level? There are 3 options that you have. That 0th candidate can either be A, it can be B, and it can be C also. Okay, now one thing is quite guaranteed, that all those candidates whose first character is A will be different from all those candidates whose first character is B, and will be different from all those candidates whose first character is C, right? So the distinction can very well be maintained, right? So what I can do is, since I have got 3 choices with me, so I will embark on to make those 3 choices. Corresponding to first choice, I want to position here some character. So let's say corresponding to first choice, I will place A over here, okay? So now my temporary string contains A. Corresponding to second choice, I would have put B over here, so now it contains B. And corresponding to third choice, I would have put C over here, so now it contains C. Okay, this input string is going to remain the same as it was, which was ABC, okay, ABC, and this one will also be ABC, okay. Now, since you have fixed your first character, okay, you have fixed your first character in all these function nodes, so where will you move? What will be the value of new index? Based on the length of string, we will make that many choices, right? Yes, based on the length of string, correct. So you have just fixed the ith character. After fixing ith character, you will move on to fix the next character, which is I plus 1. So now you would move on to fix the first character in this string, okay? First character in this string. Now tell me, when you are trying to fix the first character, okay, let's say you are trying to fix the first character in this string. So again, how many choices do you have? Can somebody tell me the number of choices that I have? I have got 2 choices, which are from here to here, okay. At this level, how many choices do you have? So ideally, if you think, you definitely have 2 choices, but those 2 choices are not B and C, rather they are A and C, because B has already been used up. So the 2 choices that I have are A and C. And similar to that, here again I have 2 choices, but those 2 choices are not C and B, rather they are A and B, because C has already been used up, right? So an important thing that you should be keeping in your mind at this point of time is that when you move down the level, then definitely, let's say you are at level 0, then the number of choices are from index 0 to index n minus 1. When you are at level 1, then the number of choices are from index 1 to n minus 1, index 1 to n minus 1. But it's not necessary that the characters in that index range will be the rightful characters to become the next character, right? Because it might very well happen that they have already been used up. So I need to do something. Can somebody suggest me what is it that I should need to do? Can we use 0, 1, 1, 1, 0, 1? Yeah, so I believe you are using a different array of booleans to ensure whether a character has been taken up or not. Yes, no? That is what you're doing. Okay, so you can do that. You can definitely do that. But think a bit more. Would that really be needed? Okay, so think in those terms. I'll come back to that. Okay, meanwhile, let us do something else. So let us try to create the entire recursion tree. See how I am going to implement this in code. I don't want you to worry about that at this point of time. Right now, just focus on the concept that how the different permutations are being generated at different levels. So how will the different levels emerge from here? Okay, so I'm trying to give an idea of that over here. Cool. So my original string was ABC, and initially I had an empty string with me, okay, and I was considering the 0th character, okay. So I was considering 0th character of this. So I had 3 choices, A, B or C. So corresponding to this, I placed A and others were empty, and now I move on to fix my first character. Corresponding to this, you fix B over here, and these are not fixed, and now you move on to fix your first character. And same thing over here, you fix C and others are not known, and you move on to fix first character, right? Now again, at this level, how many choices do you have for this character? You have got 2 choices. What are those 2 choices? Either it can be B or it can be C. So if it can be B, then you will end up getting something like this. And now you will move on to fix your second character, right? And the second choice over here was you would have placed a C over here. So if you would have placed a C over here, you would have seen something like this. After this, what should happen? After this, when you come over here, again you are trying to fix this. How many choices you have? 2 choices. Either I can have A or I can have C. So if I try to have A, I'll get BA, and then this one empty, and I move on to 2. Similarly, if I try to have a C, I will get BC, and then this will be empty. So the same thing over here. again the two choices that you make for this character, which is your first character, can either be A or it can be B. So if let's say you have A, then you end up getting something like this, and if you end up getting B over here, then you will have this kind of scenario, right? So see, at this level for all the nodes you are concerned about 0th character. At this level for all the nodes you are concerned about first character. At this level for all the nodes you are concerned about second characters, right? So this is an important observation. This will come in handy. Now at this level there are some nodes, so let's first talk about this node. How many choices do you have for this character, which is the last character? You just have one choice, right? And what is that one choice? That is C. So if you have C, you have A, B, C, right? So whenever this index I becomes equal to the length of string, don't you think this should be my termination condition? This must be my termination condition, right? Because I ended up creating a string of size n, and that is a particular permutation of the input string. Similar to that, here also for this I have just one choice, and that is to place a B over here. So I get ACB, and this is 3, and this is termination condition. Similar to this, I think now you understand, right? So you will get something here, 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 and all of those are going to be distinct. So if you take a look under this jungle, since you had fixed your first character to be A, so everything that you got are the things that are starting with A. And under this jungle, everything will be starting with B, and under this jungle, everything will be starting with C. Okay, so I hope you understand that. Now, your terminal nodes are the ones that are corresponding to the number of permutations, because you are always terminating at this terminal node where the value of I becomes n, and the value of I increases in steps of 1. Okay, so from 0 it becomes 1, then from 1 it 2, and then eventually it will become equal to n. Okay, can you tell me how many nodes are going to come over here? How many function nodes will come over here? N factorial. Okay, you are saying n factorial because you know that there are going to be n factorial different permutations, but figuratively also it makes sense. How? Let's say you are at the first node, you are at the root. How many children this root will have? Talk to me in terms of n, where n is the size of string. The number of children of the root will be n. So at this level you have got n nodes. Okay, now at this level for a particular node, how many children will be there? For a particular node, how many children will be there? N minus 1, right? So since there are n nodes, and there are n nodes, and for every node there are n minus 1 transitions, so total number of nodes will be n into n minus 1. Below that, for every node again there are these many nodes over here, and for all of them number of transitions will be n minus 2, so it will be n into n minus 1, n minus 2, and eventually at the last level, like here the last level is 1, you will see that for the last level there are one transition, there is just one transition, so the number of leaves will be simply equal to n factorial. So this recursion tree very well explains that I will be generating all those n factorial distinct permutations without any miss and without any duplication. But now the question is that how do we do that? So as some of you suggested, one of the ways of doing that could be that you use a separate string, okay, and then while you are using that string, answer me one question. How would you want to pass that string? Answer after thinking. If this is your temporary string which is containing all the different permutations, would you want to pass it by reference or would you want to pass it by value? Okay, so many of you are saying by reference. Tell me one thing, if you are passing it by reference, first this node will execute, this entire tree will execute, and then this will begin, right? Here you had already appended A over here. Okay, so here if you try to append this B, that will not come at this position, that will come at some later position, right? So if you do that, that's not great thing, because the same string that you are sharing across all the function calls will be getting tampered value, since we don't have index. Yeah, correct, because this is a string and not a character array. Okay, so that is the first problem, and this is a huge problem over here, because the number of permutations that I am having is n factorial, and the number of combinations that I used to have was equal to 2 raised to power n. Which value is mathematically bigger? Is 2 raised to power n bigger or is n factorial bigger? Okay, so most of you are saying n factorial, and that is in fact very big. Why is that big? Because in 2 raised to power n, the highest power of the highest base of n is 2. But if you talk about this, you get something like this: n into n minus 1 into n minus 2 and so on. Here you will definitely have a power of n as n raised to power n followed by something else. And since those are of smaller powers, so you can ignore them, and this will be something like n raised to power n, and n raised to power n will be greater than 2 raised to power n if this n was greater than 2. So here, since the number of function calls will be tremendously high, the chances of memory limit being exceeded will also be very high if you are creating a new string at every function call. Can't we use char temporary array and track? You can use a temporary array, but just using temporary array is not going to be enough, because you need to do something else also. And what is that something else that you need to do? Whatever this string is, okay, you need to manipulate this one also. You want to manipulate this input string as well. However, the intention that I have over here is that, can I solve this problem without using any other extra string or extra temporary array? Can I do that? So the answer is yes, and this is a very important thing that we are going to learn right now, and let us see how we achieve that. Okay, so first, all of you understand this, that if a string is passed by reference, then that string gets tampered, and because of that, what you want to do over here, that you will not be actually able to do over here. Okay, so let us see how to achieve our target. So I'm going to just erase this. Now let us just try to understand one thing. So let's say your original input string is string S, which is ABC. Okay, how do you pass a string by reference? So there are different ways to pass it in Java, like when you pass it is already passed by reference. In C++, you can just add this. If you write like this, then this string is considered as passed by reference, right? So let us just play around with this string and then somehow see if I can get my job done. So this is my string, okay? So currently my index is 0. Index 0 means I'm trying to estimate different options for 0th character. So how many contenders are there for 0th character? The number of contenders for 0th character are from 0 to n minus 1, which is n different combinations, right? So what I'll say that, hey, what I'll actually do is, there will be one branch like this, another branch like this, another branch like this. So the first contender will be this A itself. So you will call for ABC itself, right? And then you will move on to next index. But the next contender will be B. Okay, so when the next contender will be B, then you would want that this B comes over here. You are playing around with the same string, right? So you would want that B comes over there. How will B come over there? For B to come over there, B needs to be swapped with A, isn't it? Yeah. So you need to swap that B with A. You swap this B with A and you end up getting BAC, and then you move on to next index, which is index 1. Here, you would want that your first character becomes C, so you would swap A and C, right? So you will end up getting C, B, A, and now you will move on to first index. If I were to generalize it, I am saying that if you are fixing your 0th character, then your options are from 0 to n minus 1, and for all those contenders, to place that contender at this position, you are performing a swap of this with that contender. That is the reason you got CBA over here, and when you swapped A with B, because you wanted B to be here, so you got BAC. And after having done that, now you move on to 1. So basically you're trying to see that for this first index, how many different options do I have? Okay, so there are some actions that you have performed, and one thing which is very important is that this string is passed by reference. This is not passed by value. So I'll just track what I am doing. So first thing that I did over here is, this was like, swapping 0th character and first character. This can be thought of like swapping 0th character with 0th character only. This can be thought of like swapping 0th character with 0th character. You get that thing only, okay? And this can be thought of like swapping 0th character with second character, okay? So first you perform this action and then you make this function call, and then only those things will happen. So those things are on hold. So you perform this action and then you make this function call. So now what is going to happen? Now you are at index 1. So when you are at index 1, how many choices do you have? You have got 2 choices, right? So for this index 1, the contenders are index 1 and index 2. So first thing that you can do is you can swap index 1 with index 1 itself. If you do that, you get back this ABC, okay, and then you move on to next character, which is character 2, okay. And if you had done the reverse of it, what is the reverse of it? Sorry, not the reverse of it. If you had done the other thing where you had swapped first character with second character, in that case you would have gotten ACB, and now you move over here. So now the value of I is equal to n minus 1. Tell me one thing, guys, whenever the value of I is equal to n minus 1, then you just have one option with you, which is swapping this character with this character itself. So can I not terminate over here? I can terminate over here itself, right? So this can be thought of as my termination condition. No need of going one step down further, because you just have one option here. So you will swap this with itself. So that will be like a useless operation. You can perform that, but all that I am saying is it is not needed to perform that. Okay. So this can be your termination condition, and you can simply print this out. Okay. After you have printed it out, what will happen? So this will return, and now the control will go back to this. Okay. Now when the control goes back to this, so this swap thing will happen. When the swap thing happens, so it swaps B with C, and you end up getting ACB. And when you end up getting ACB, you print it out. Okay. Now what will happen? Now the control from here will transfer here. Okay. This is also over. So the control from here will transfer here. Tell me one thing, guys. By the time control from here transfers here and then transfers here, how will this string look like? Because this was passed by reference. Will it continue to be ABC, or would it have got changed? It would have got changed, right? Because it was passed by reference. So when the control comes back to this point, you will get ACB. And with ACB, if you perform a swap of 0, 1, what will you get? If you swap 0, 1 from ACB, you will get CAB. But you wanted to get this. So the problem will get created. So now, how do I prevent it? How do I ensure that once the control reaches here, then this string should start looking like how it was exactly looking? Copy parent string, not a great idea, because again you are using a separate string. We need to backtrack, undo, yeah, that's right. So that is what we need to do. So see, if you take any path, that path had some changes made in the string. Okay, so you performed certain actions in the string. So in recursion, what happens that the call flow is from root to the leaf, but the return flow is from leaf to the root. So let us understand one thing. If let's say there is an array, okay, so forget about this for a while. Let's say there is an array 1, 2, 3, and then you performed some actions on it. So action 1 is to swap index 0 with index 1. So if you swap index 0 with index 1, you will get 2, 1, 3. And then action 2 has been performed, which is to swap index 1 with index 2. If you do that, you will get 2, 3, 1. Okay. If you want to travel back from here to here, if you want to restore this into this, in which order will you perform these actions? I mean, in which order will you undo these actions? Will you first perform 2 and then 1, or will you first perform 1 and then 2? You will first perform 2 and then you will want to perform 1. So this is an important thing. So this can be thought of as do 1. You did action 1, do 2. But if you have to restore it, undo will first be called on action 2, and then undo should be done for action 1. That should exactly be the thing to be done over here also, because if you take a look, first this will return. So when this has returned, this was the function call which had performed a swap. After performing swap, this made a function call, and when this function call is over, then it is the responsibility of this function call to call unswap. Unswap means swapping the things back again. So it will unswap 1 and 2 again. So when it unswaps 1 and 2 again, when this function is over, so what will happen? As a result of that, CB will get swapped, and now it will become ABC. Now again, when call passes over here, so that is being done by every function call. Whatever function call performs a swap, after swap, it makes a new function call, and when that function call is over, then it performs unswap. So that way, when control passes from here to here, unswap of 1 2 happened, so ACB converted to ABC, and then unswap of 0 0 happened, so ABC converted to ABC. Unswap is just like swapping those two characters back again. So this is a very important thing using which you are basically what you are doing, you have the same string and you are very intelligently playing around with the same string and getting your job done. Okay, now when you are back to here, so your string starts looking like how it was. One more thing, I am going to call it here itself. Whenever there is, let's say it is the parent, okay, now parent tampers the input and then calls its child. So whenever the child is over, then parent should undo its action so that the input starts looking how it originally was. Okay, this is the intention, and this will always happen. Let's say now you're over here. Okay, so now here you will perform a swap of 0 1. So if you perform a swap of 0 1, this ABC is still ABC because of the actions that you performed, right? So now if the swap of 0 1 is performed, you will end up getting BAC. Now when this is over, then you will perform unswap of 0 1. This is on hold, right? When this function call returns, then you will perform unswap of 0 1 so that this BAC turns back to ABC, right? Now you are at index 1. So at index 1, how many options you have again? How many different options that you have for this index 1 character? You again have 2 options, right? And what are those 2 options? You can either have A over there or you can either have C over there. So what will your first action be? Your first action be to perform a swap of 1 with 1. If you perform a swap of 1 with 1, you will get BAC and you will move on to next index, which is 2. Okay. Now when this function call is over, which will get over here, it will terminate because of termination condition, then unswap of 1 1 will happen. Unswap of 1 1 will just swap A with A and you will get back this thing, right? Next what would happen? Another option for you was to perform a swap of first character with second character. So if you swap first and second character, BAC will get converted to BCA. And now you will move on to next index, which is index 2. Now this again is your termination condition. Now when this returns, then the unswap of this will happen. So when the unswap of 1 2 happens, then what happens? BCA gets converted to BAC. Now this is over. So now unswap of 0 1 will happen. So BAC will get converted to ABC. So did you notice it, guys, that whenever the control reaches back to the parent, the input is restored into its original state? And this is exactly what you need, right? So the point over here is that whatever you do, okay, you fix that. Whatever you do, you fix that. And why you are able to fix that in the right manner is because the first action is being undone in the last and the last action is being undone in the first. And why is that happening? That is happening because of the nature of recursion. Because control flows from top to bottom, okay, which is like you did like this and you undid like this. So now I think you can think of it again now, right? So now this is restored to this. So if you try to swap 0 and 2, so you will actually from ABC end up getting CBA, right? And now you will be interested in first character. Now tell me one thing. So what is the first thing that you do? First thing that you do is tamper with the input, which is swap. Then you make the function call. When the function call is over, then you perform the unswap of whatever you had swapped. Okay, so this is on hold right now. Now you are at index 1. How many options? 2 options. You can swap 1 with 1 or 1 with 2. Okay, so let us perform first action where you swap 1 with 1. So if you swap 1 with 1, you will get CBA and move on to index 2, which is your termination condition. Now when this terminates, you will unswap whatever you had swapped. Okay, so what will happen? Swapping 1 with 1 will give you back this thing only. Second option that you had over here was to perform a swap of 1 with 2. So if you swap 1 with 2, you will get CAB and you will move on to next index. Now this again is your termination condition. When it returns, then you will perform unswap of 1 and 2. So if you perform unswap of 1 and 2 from CAB, you will get CBA. Now when this returns, then first unswap of 0 2 will happen. So 0 2 means CNA and you get back ABC. So this particular thing that I have here, I just use one string, which is in fact the input string only. I did not even create any extra string. I just used the input string and I played my game with it of swap function call and when the function call is over, then unswap. Okay, doing that thing, I was able to use the same string to print different permutations of it. Okay, so here I am not using any other extra string for getting this thing done. So if you understand the basic philosophy of this, the basic philosophy is that you swap. Okay, after swapping you make function call and then you unswap. Okay, this is the basic philosophy. If I generalize it, it is something like swap is like doing something. You do something to the input and then you recurse or make function call, whatever you call it, and when this is over, then you undo. Okay, why do you undo? Because when, let's say, you have recursed, okay, and let's say called a function, whatever you did, you want to undo that. If you don't undo that, then your next call will not give you the input transformed in the way in which you wanted, right? So this thing of doing, then recursing, and then undoing whatever you did, this is called as backtracking. Backtracking is just the single line thing. If you figure out do, recurse and undo, then your job becomes extremely easy. Okay, so here do is like swap, so the undo of that is like unswap. So backtracking is immensely helpful. Why it is immensely helpful? Because it drastically reduces your space complexity. You do not have to use extra input, extra string or something like that. You can play around with the same string and you can still get your job done. Okay, so let us just try to write the code for this. So let's say I am trying to write this function called as permute. Okay, can somebody tell me how many parameters should I accept? Let's say I have input string is my input, forget about character for a while. So there are two inputs that I need a string and I need I also, right? I index, because I is the source of my figuring out termination condition. I will determine that how many options do I have. Okay, okay, now again to generalize, whenever you are at index I, then how many options you have? The options that you have are from I to n minus 1, right? And for corresponding to every of those options, you would want to make a new function call. So there will be so many function calls that you will be making. So can somebody tell me how can I make that? I need to write a for loop. Yeah, using a for loop, I'll iterate from I till n minus 1 and then swap with that particular character and then call the function. And when that function call is happened, I will unswap whatever I had swapped. So I'll have a string passed by reference and I'll have this index passed by value, because indices need not be same. Indices will be different, okay, at different places. I just have to print the value, so I'll keep it void. Okay. So tell me, what is the first line of code that I should write? How do I track my termination condition? So yeah, whenever I see that index is pointing to the last index of the string, so if I happen to see that this value of index is equal to s dot length minus 1, then what should I do? Then I should simply print my string and I should return. Okay, so this is my termination condition, right? Corresponding to the last level, which is n minus 1th level. For all other values of I, it simply implies that you are not at your termination condition. So if you're not at your termination condition, then you have to do many things. You have to do many function calls. And now, before any function call, what is it that you have to do? You have to perform a swap, right? So first you have to swap, then you have to call the function, and then when the function call is over, then you have to unswap. So let us see how I can do that. So the number of options that I have for a particular value of I, it is from I to n minus 1. So let me iterate. So I can iterate using j equals to I to s dot length minus 1. So I'll iterate from here to here. So any value of j at any point of time simply tells me that, hey, currently I am trying to swap my ith character with jth character. That is what j means, right? So what is the first thing that I should do? First I should perform a swap, right? So I should do a swap of what? I should do a swap of si with sj. After performing this swap, the next thing that I should do is, so first you do this and then you call this, right? Do and then recurse. Then I will make my function call. So my function call will be permute, where I'll pass this string by reference, And what will be the value of index that I should pass? How is your index changing? Will it be equal to j? Think again. Whenever you move down the level, your I becomes I plus 1, right? Because I means that you have fixed your ith character. Now you need to fix your I plus 1th character, right? So your I will always change to I plus 1. So now you will call S and this will be I plus 1, right? And what will be the last thing that you will do? Before loop runs again and makes a different function call, the next thing which you will want to do is you will want to perform unswap of this. So unswap is just like swapping the two characters back again. That's it, just this much of code and that much of job gets done. Is it clear to everyone? Did everyone understand the code? Pruning and backtracking are different things, right? Because I used pruning is entirely different from backtracking. Backtracking is a concept where you what do? In backtracking, you simply use one input and tamper that input itself at different nodes and recover it by undoing whatever you did. Pruning is something different. Pruning means that you avoid some function calls from being made. So see, what is the meaning of I? I denotes level in your recursion tree. Level in your recursion tree means that currently you are interested in fixing your ith character. Once you have fixed your ith character, then it is your responsibility to move to I plus 1th character. Okay, I plus 1th character. So this was a string that had all the distinct characters and my job got done over here. Can somebody tell me, am I printing the permutations in a lexicographic way? Are the permutations being printed lexicographically? It is not. It is clearly not getting printed lexicographically. Why? Because, of course, you have ABC over here. ABC is the first thing that you print, and ABC is smaller than ACB. So I am happy till here. Then I have BAC. So here also I am good. Then BCA, here also I am good. CBA, here also I am good. But CAB, what do you think? Is the last order correct? No, it is not. So now the next question from my side is this. Can I print the strings in lexicographic way? If yes, then what change should I make to this code to let that happen? So guys, see, whenever you see that something is not happening, like here you see that lexicographic printing is not happening, right? So you should try to find the root cause of that. So root cause means what is it which is not allowing the strings to be printed in lexicographic manner. Okay, once you figure out that root cause, you just have to then fix that root cause and then automatically things will start working. Tell me one thing, what is the most brute force way of solving this problem, which is printing the strings in lexicographic way? If nothing is coming into your mind, what will you finally do to somehow code it out? I think it is very easy to think. Yeah, so you can store all the strings that you have generated so far in a vector of strings and then sort that vector lexicographically. But can you tell me what is it that is not so good about this approach? Yeah, sorting will take extra time, and another thing is that for storing these many strings, the quantity of string is n factorial. So storing n factorial strings might not even be possible in some of the cases. So that is also not a very great idea. Did you get it? So from both space and time point of view, that is not a great option. That is not a great thing that I should do. So can I somehow mold my current algorithm itself, my current code itself, to print things out lexicographically? So let us understand one thing. How many of you thought that, hey, I mean, you can just let me know that, because that is also an intuitive thought. How many of you thought that if the original string is sorted in terms of character, then all the permutations will also be sorted? I think that is a good enough way to think of it, because I'll give you one. Okay, so Jairaj is saying if Si is greater than Sj, then swap. But if you do that, then you might end up missing some of the, permutations, isn't it? Because whatever you are saying, if you do that, you are saying you will swap this with this only if this is smaller than this, then that is not the right thing to do. Okay, so you swap Si with Sj for all different relationships between Si and Sj. Did you get it? So that is not the viable thing to be done. Okay, so let me give you one solution. See, if the string is sorted, then what did I say? I said that, hey, first I am going to generate all the strings that start with A, and then all the strings that start with B, and then all the strings that start with C. So this gives us a hint that, hey, it should print the things out in lexicographic manner. It gives us a hint like that. But you know, it totally depends upon that whatever is your remaining string. So let's say if you are at level 1, then the remaining string is from here to here. Your remaining string should also be sorted, because if your remaining string is not sorted, then this argument does not hold, right? And that is exactly the case over here. Let us try to understand that. So here, after you have swapped 0 with 0, you have ABC. Now this is your remainder string. Is it sorted? Yes, this is sorted, and that's the reason your output are also sorted. Same here, your remainder string is sorted, and that is the reason your output are also sorted. But here, is your remainder sorted? No, and that is the reason the output came out unsorted. Did you understand it conceptually? Why is it happening? So what is it that I'm supposed to do? What should I do? I should do something like this, that whenever I move down, then whatever is the remaining string, whatever is the remaining suffix, that should be sorted. Okay, if that is sorted, then everything is good for me. Tell me this thing, does that make sense to everyone? If the remaining string that I have, if I sort it and then make the function calls, then my life will become easy. That after swapping, you sort the remaining string. But tell me one thing, is that really needed? Or think of it in this way. Let's say you had a string like A, B, C, D, E. So let's say for this you had multiple options, swapping A with A with B, A with C, A with D, and A with E. So let's say you are trying to swap A with D. So if you swap A with D, you will get D, B, C, A, E. And then you will say that, hey, I'll then sort this much part, and then you will get D, A, B, C, E, right? So you achieved this to this via sorting. Is it really required to sort it? Do you really think it is required to sort it? It is not required to sort it. Why? Because the original string itself is sorted. So if you sort it, it will take n log n time. But what you can do is, instead of sorting, you can simply do a left rotation. So if you simply left rotate it, then what will happen? Left rotating is like C comes here, D comes here, A comes here, and D goes here. So you will end up getting this exact same thing, and this left rotation by 1 unit will just take you order n time. Okay, so what is your intention? Tell me. Your intention is that, let's say if you have brought the jth character at ith character, then the portion from I plus 1 to n minus 1 should remain sorted. Then only lexicographic ordering will be maintained. One way to maintain that is, after you have performed the swap, like you performed the swap over here and you got this. After you have performed the swap, then sort this much of area. But sorting is an expensive operation because sorting takes you n log n time. So instead of sorting, can you do something else? Yes. Why? Because your original input was sorted. And if it was not sorted, you sort it. You can sort a string very easily, right? So what you should do, instead of doing this thing, what you can do is, don't swap Si and Sj, just right rotate from J till I. So right rotation means what? Bringing this over here and shifting all these by 1 unit towards right. So what will that do? D comes over here, and then A moves here, B moves here, and C moves here. So this operation of rotation, how much will it cost? At max it can cost order n. It will never cost more than order n. So definitely your complexity will become n times of what it was, but that is okay because it was already very high, and n raised to power n multiplied by n is still better than sorting that thing, because that would have been even greater. So if I sort and then if I left rotate, so instead of swapping ith character with jth character, I am saying that, hey, you perform left rotation of the portion of the string which is from I till j, and after this left rotation only you make this call. So what should be the undo then? What should be the undo for left rotate? Because you want, when the function call is over and the control comes back to the calling function, the string is as it was. Yes. So the undo of left rotate will be right rotate. So after having invoked this, now you will call right rotate. Okay, so that will ensure that when that function call is over, then if you had converted it to DABC, now when you right rotate, then what will happen? Right rotating means this comes here, this comes here, this comes here, and this goes there. So string turns back to how it was. Simple change, right? Instead of swap operations, you have introduced rotations. And the only most important thing is that these two things must always be consistent. This must be undo of this. Okay, then only your approach is going to work. Then only your next calls will be consistent with your thought process. So I think this way you can print all the permutations in lexicographic order as well.